Hi everyone, I'm Nate and welcome to Elevate with Nate, a place for learning, growth and self-improvement. Join me as we explore a wide range of topics, sharing insights and new knowledge from my personal learning journey. Today we're diving into the fascinating world of Starlink, SpaceX's ambitious satellite internet project. And in case you're not aware, SpaceX is the private exploration company founded by Elon Musk. So, what exactly is Starlink? And as I mentioned previously, it is a satellite internet provider whose main goal is to provide fast internet with low latency to every corner of the globe, in particular to areas which currently are underserviced and haven't got great access to the internet. As I've discussed in a previous video on the internet and Wi-Fi, linked above somewhere, internet traditionally relies upon underground cables, cell towers, submarine cables, and it can often be expensive, especially to get this to remote areas. Whereas with Starlink, it relies upon low Earth orbit satellites, which essentially beam down the internet to your dishes. So how does it actually work, this Starlink? Well, SpaceX will send a group of small satellites into low Earth orbit, roughly 340 miles above the surface. And this will create a network or a constellation which will be able to essentially provide internet to currently certain areas of the Earth, such as North America, parts of Europe, some parts of South America, some parts of Asia. And then you, the user, will have a Starlink dish, which apparently is often called Dishy McFlatface. Quite why, I'm not too certain, but I like that name. And these dishes can be set up either in your home, businesses, or even potentially in moving vehicles. And essentially, it will send a signal from the dish to the satellite and back, providing you with your high-speed internet. Right, so I want to give an example of exactly how the whole process will work from you on your phone requesting something to gain the information back. So imagine this, on your phone or your laptop, whatever, and you try to search something on the internet. So you put it now in a request. This request will of course go in your house to your router, and from that point it will then pass that request to this dish which you have, the Starlink dish, which will in turn send via radio wave that request to the satellite up in the sky. And at this point the satellites have to now determine what is the quickest way to get your data request down to the ground stations, aka the gateways, which are physically in place across the world, made by SpaceX. And often, if the satellite, which currently has a request, is not the closest position above to the ground centre, then the satellite will pass it on to the next one, until it finds the best location to beam it back down. And once the ground station or network has your data request, now it's quite similar to how your normal internet would work in your current homes. So it'll send it across via, let's say, fibre optic cables to a data centre with the servers, which will then action your request. And then in reverse, it'll do the exact same thing. It goes back along the cables to the ground centre, ping it back up to the satellites, and then bounce it back to your correct satellite, which will then, in course, send it back down to your disk and then back to your device. Now, you may be asking, well, can we use this technology with your mobile phones when you haven't got Wi-Fi? So let's say outdoors. And the answer is yes and no for now. Back at the start of 2024 in January, they began to offer text messaging systems, so you could send SMS texts using the Starlink system. But you couldn't yet do anything more complex. But apparently by 2025, you'll be able to do voice calls and other good bits and bobs. So, fingers crossed for that. And this is pretty actually game-changing if you think about it, because in rural areas, if there are no cell towers around, well, you have no access to any 3 or 4G. I can tell from experience currently. I was recently in Canada, in the Rocky Mountains, and once you'd left any kind of nearby town or village, there was nothing. For about an hour and a half, I had zero cell service, nothing for my 4G or 3G, nothing. So with this Starlink, that'd be fantastic. It wouldn't matter where you are. It could be in the middle of the desert, middle of the mountains, top of Everest, and you could get some signal. Right, so let's discuss some of the main benefits of Starlink. Man, I actually just mentioned it right there to you. The main thing I would say is is that this can be accessed anywhere, even in the most remote rural areas. Just think about it. The chance of this being rolled out by the usual ISPs, internet service providers, is pretty slim because they have to physically put in, let's say, the cables underneath the ground, they have to have the cell towers nearby for you to get access to their internet. And if you're miles and miles away from anything, they're just not going to do that. It wouldn't be cost effective for one house or one person on the road. So they won't do that. Whereas for this service with Starlink, that will be possible. And in case you want to know a bit about the specs, the download speed is quoted at roughly between 40 to 220 plus megabytes per second, which isn't too bad if you consider that 4G is meant to go up to roughly 100 megabytes per second. So you're beating 4G. Now, 5G can go quite a bit higher, up to roughly a gig or so. But at a starting point, that's not bad at all, see what is offered by Starlink. And then the latency is also pretty quick, between 25 to 60 milliseconds, so that's very good there. So, we've discussed the positives and the pros of Starlink. Let's now discuss the potential challenges and criticisms of Starlink. And the first will be potential space debris. Because with thousands of satellites planned, there's a risk of collisions which will, endanger other satellites that are up there, but also potential space expeditions too. Secondly, astronomers have raised a concern that the bright coloured satellites are interfering with observations. Now, SpaceX have tried to work on this, darkening their satellites, but there's still something which needs to be worked on. A third, and I think probably biggest concern, is actually due to line of sight. For Starlink's tech to properly work, your dish has to have a direct line of sight with the satellite. So now imagine if you're in a quite urban, dense location, say in a city, and you're blocked by a big skyscraper, or you're in a dense forest on some trees. There's a good chance that your connection will be very, very poor because the satellite can't quite see your dish. And for me, that's pretty massive there, because ideally for this tech, you want to use it everywhere in the world, whether it's rural or urban. So that means quite a big issue which they need to kind of somehow work on. Now, sure, you might say, if they can't fix this, then tough, just use this if you're in a rural area, and if you're in an urban area, use the current stuff. But that's not ideal. You want to have this working everywhere. And then our final fourth concern is, for optimal signal strength, you want clear skies. So if you have clouds, rain, snow, that's going to cause issues with the signal strength. So for me personally here in the UK, this doesn't sound very promising for me. So yes, that's quite a big issue. So to conclude, it is clear for me that Starlink represents a major step forward in global connectivity, and its ambitious project will definitely help a lot of people out, especially in more rural areas, and hopefully they can sort out and fix these potential challenges. Thanks for watching. If you enjoyed this video, please give it a thumbs up and hit that subscribe button and bell notification. Feel free to leave any comments and any suggestions for future content. And as ever, onwards and upwards.